Good afternoon, everybody, and welcome. Let's give everybody a moment to settle in, and then we will get started right away. All right. So, again, welcome. I'm David. I'm head of community here at Siemens Accelerator, and I'll be your moderator for the next 30 to 45 minutes. I'm looking forward to having you here in the chat. And let me start with a simple question, and I encourage you to genuinely sit with it for a second. Are your machines running as fast as they could be? Not as fast as you have set them to run, as fast as they physically could. Because for most manufacturers, those two numbers are not the same, and the gap between them is what we're talking about today. Trial and error, conservative parameters, toolpath, programmed by instinct and experience, then dial back to be safe. It's how the industry has always worked, and it quietly cost manufacturers enormous amounts of time, capacity, and money, without anyone ever naming it a problem because it's just normal. Today, we're going to challenge that. We're going to talk about what it looks like when you replace guesswork with physics and what that means for a machine shop trying to compete, reshore work, or simply do more with what they already have. I'm joined today by four people who live this challenge from very different angles. We have Dr. Erdem Öztürk, founder and CEO of Productive Machines, 20 years in machining, dynamics research, and the brain behind SenseNC, the first autonomous toolpath optimization software embedded in Siemens NX CAM. Dr. Garrett Morgan is managing director of AML Sheffield, a precision machining company serving the aerospace and defense sector. And we have Professor Sam Turner, CEO of AMIC, the Advanced Manufacturing Innovation Center at Queen's University, Belfast. And lastly, our very own Armin Grunewald, our VP of Part Manufacturing here at Siemens and responsible for NX CAM. Gentlemen, it's great to have you here today. Welcome to this discussion. I'm looking forward to it. And for our participants watching right now, welcome again. We are live. This means you can ask questions in the chat at any time, and we will make sure to get back to you either directly in the chat or later in our Q&A session at the end of this conversation. So let's get into it. I want to start where every manufacturer starts, on the shop floor, with the reality of what's actually happening. And I would like to open this up to the whole panel because I think the honest answer to this question looks different depending on where you sit. So let me ask it directly to you guys. Why are machines still underutilized today? This isn't a new problem. We have experienced programmers, capable machines, sophisticated CAM software. So what's actually getting in the way? Who wants to start? Maybe Erdem?
Yeah, I can start with my perspective. From my perspective, humans are basically have some tools in their disposal to create programs, to create G-codes that the machines understand. So they basically use CAM software like Siemens NX CAM is a great software. Historically, Siemens CAM software like Siemens NX CAM have been supporting CAM programmers with the geometry of the process. But the manufacturing engineers or CAM programmers didn't have visibility about the physics of the process. So they don't know whether the tools will break or whether there'll be vibrations in the process or whether there will be excessive vibrations. They don't have that visibility when they are programming the toolpaths, creating the G-codes. For that reason, they face the reality of the physics when they press the cycle start button. And then they start iterations, and humans have limited time to deliver outcomes like products. Basically, in their limited time, they may be doing optimizations by doing iterations, by doing trial and error of the machines. But it's really difficult for them to find the optimum conditions, global optimum conditions for a machine to consider that they are working in a high stressful situation as well. So yeah, practically, I can easily say that most machines are not running at the maximum potential of them because of those reasons. So just to summarize, like they don't have the technology available to them, and even if they have some technologies and they are usually running in high stressful environments, they have to deliver the parts on time. For that reason, I think those are the main two reasons I think for that.
Okay. Anything to add to what Erdem said? Garrett, Sam, Armin?
Yeah, so just to chime in, so I run a company that's just finishing at the M end of SME, small to medium enterprise. And we've gone for a journey of being a very small 2-machine shop into something slightly bigger now. And the other issue I'd chime in with Erdem, because I completely agree, is the value per asset of machine tool that you're often using is exorbitant. It's a high value machine. You're very nervous about how far you can push the process. There is only, without using physics, as Erdem has described, there is only advice available, not fact. So people get parameters, get some kind of rules of thumb, and they don't simulate or optimize around the forces, the vibrations, and therefore they do leave a lot of capability and capacity on the table. But that also chimes in with the value of some of the component groups, and also naturally the value of the machines. So it's understandable why people are nervous and why they're only have an element of view of being conservative. But more and more, to get the right position commercially and to be competitive globally, because it is a global world making complex components, precision machine parts, then you have to push every lever you have. And we've had successful history of working with people like Erdem to optimize these processes.
Yeah,
I have one. Oh, sorry, you go first, Sam.
Okay. Yeah. Thanks, Simon. Yeah, I'd like to back up really and build what Erdem and Gareth have both said. I mean, one thing people may think about getting productivity performance out of their machines and their assets being OEE. You know, the green light's on, therefore we're getting value. But I think the point we're hearing here is that get the most productive process, getting the greatest yield from that machine and that asset, isn't straightforward without that scientific insight, the physics-based modeling that helps you do that with confidence, as Gareth has said, as a machining company owner. And I think there's a need to. Erdem talked about the surprise. If you take that risk and then you find out you know damaging tools, spindles, actually more time required to validate programs, that means you're not actually delivering high productive. And we see businesses getting something that's just about, you know, that's operational, that makes the part that delivers the order, with an aspiration to come back later and improve process cycle time, improve productivity. But the reality is often there's not the time to do that. So getting things right first time requires a physics-based scientific approach in the first place. And I think increasingly, if you can do the develop and validate as far as possible a process in the virtual world, there's then no surprises when you validate that in the physical world. So, and that's a real strength, I think, of the solution, the SenseNC solution, that it is a step forward in terms of having that level of robust simulation. That means you've got a probability, you know, when you deliver this and turn on the machine, you're going to have a highly productive and a stable process, because productivity and stability are really what businesses are looking for.
Yeah, let me add another thought. I mean, you said that we have skilled people. I'm not sure if this will be true in the future the same way. Maybe I can speak up. I'm probably the oldest one here in the crowd looking at you guys. So when I go and retire one day, you guys still have to fight for that. But Sam, you spent energy in teaching people, right, the next generation of engineers. And I just want to give this other ball into the discussion. I think we are leaving a lot of potential on the table, and I think that's what Erdem also said. By having the technology, having in theory all the technology on the machine, on the CAM system, on the whatever technology available, but don't have the time or don't have the skills or don't have the, you know, the risk readiness to play really to the maximum. How many of you using Microsoft tools? How many buttons did you never push in Microsoft Excel, right? And you don't even know that they exist. And if you do some statistics here, this is a very low percentage. So making maybe the link later on, we may discuss that again. I mean, what we at Siemens trying to do, the power of AI, right? I mean, AI is pretty much in every conversation we have these days. Maybe just a thought, how can we help the shortcut of skilled people? And maybe in some of our countries in Europe, in the US, we still have some people, but even here and in the emerging countries, we are lacking this all over the place. So that's maybe an angle where we also need to think how we can get this feedback from the real machine back into that AI monster and feed this feedback into new generation of engineers and help people to enjoy these learning, not only on the high sophisticated aerospace complex parts, but also here, but also in the future, more on the next generation users. Let's call it this way.
Yeah. So thank you, guys. And I mean, now we talked a little bit about the problem from all the different angles, and I think Erdem, that's exactly where productive machines, set out to change something. And I think you prepared something for us today to talk a little bit about how productive machines and your solutions can actually make a difference. Would you like to walk us through?
Yeah, of course. Let me share my screen. So we have this SenseNC software that Sam mentioned. We have applied this software solution into many companies. For example, AML will be sharing their experience in a moment. So I will just share a few slides about it. Just give me a second. Coming. I think you can see my screen. SenseNC software, as the name implies, senses the NC files before the codes CAM programs go to the machine. So one product we have called is SenseNC feeds. As the name implies, it's optimizing the feed rates, and it considers the physical loading on the tools, like forces, torque, power limits, bending moments, and stress levels. And the second product is Finesse. It also considers a really hard problem called chatter vibrations. So chatter vibrations could be the limiting factor in productivity in many cases, for example. So it also considers that. I will show you like the user interface of the SenseNC solution in a moment. One thing I would add to Armin's point was, again, related to my time pressures, ease of use. If this technology is difficult to use, usually the adoption will be very low. But what we have developed with SenseNC, we have developed a workflow that does really fit well with the CAM engineers' workflow. So they create a CAM program. So let me run it.
To show you how to.
Can you see the screen playing? Yeah. So basically, it's running inside the Siemens NX CAM. The user logs in with a username and password. This solution is running on a cloud server, or it can also run on an on-premise server, considering the sensitivities of the companies, especially in aerospace and defense sector. The only user input is required is basically what machine you are cutting, what tool holders and tools are used. Some of the information is already available in Siemens NX CAM, so you may not even need to add some of this input. And then what operations need optimizing. So you see like there's about 10, 20 operations there. So you could want to optimize some of them or all of them. So it's the user decision. And the good thing that the last thing is the material. So basically the user asks the material, needs to tell us what material they are cutting, and that's it. That's basically the job done by the CAM programmer. Now it's replaying again the same thing. So it takes about a minute or two to basically request optimization. And then the user basically gets an email saying that the optimization has been completed with certain KPIs. KPIs could be chatter mitigation performance, or it could be cycle time reduction performance, or productivity increase performance. And all of these operations, even if there are 350 operations, they are all processed in parallel. So in a very quick time, in a very quick short period, the user gets what they need, and basically they get new optimized operations inside NX CAM. And what I will show you, and also is I'm showing a QR code here. This product, SenseNC Feeds, is available in the Siemens marketplace. If the audience scans this code, they can basically start downloading and then using it the next day. And one more thing I will show you is this. This is quite a powerful demonstration. I will show you two videos. One video is from the original process. Second video is from the optimized process. And this machining has been done in the AMIC in Sam's facility. So they had this process where the spindle speed was about 6,000 RPM, feed rate was about 800 millimeter per minute. And our software identified that there will be problems in that process before even going to the machine, and optimize it, created new operations inside the NX CAM, and then you'll be able to see the difference there. First, I will play the original one. So this might have been disturbing to hear, but there are operators or the engineers that are listening to this kind of noise every day if there are shutter vibration problems happening. Now I'll play the optimized one. So as you can hear, this is much quieter, and the productivity is about 3 times compared to the original here. So we are solving a problem, first of all, because shutter vibrations are causing tool wear problems, maintenance cost increases, increase in tooling cost, and surface quality problems. So those are the problems that are solved with optimization. But at the same time, optimization gives 3 times the productivity increase. This is, of course, an extreme case here, but in general, we see 20 to 25% improvement in overall productivity per part with this technology.
All right.
Stopping sharing.
Pretty impressive. Thanks for sharing. Very insightful. Gareth, Sam, hearing Erdem talk about and describing the problem and solving, does that match with what you saw on the shop floor when you first used it? And how easy was it to get started?
Yeah, so from our side, I mean, after a bit of my background, unfortunately, the DR in front of my name, which is not as a high value as prof in front of Sam's, but both our research background is in this whole field of machining dynamics and machine optimization. We've worked together on different R&D projects in previous lives. And we've been around some of this R&D for a long time, and it has been a true R&D subject for, I'm going to say 50 years. Maybe it's a little shorter, maybe less, something like that. And the issue why it's not being implemented, I think, goes right back to Armin's point about who can champion it, who's skilled, and the barrier to entry to implementing it. The knowledge might have been there, but how do you implement something when it's appropriate for what I would call a normal manufacturing company to ingest and apply? And I would say I've been around other solutions, and I can highly recommend the work that Siemens and Productive Machines have done to make it more integrated to how the CAM process works with engineers that don't have to be research capable, but can still apply the technology without necessarily as the higher skill level as maybe some of the pure R&D field where some of this subject matter is led. So from our side, we have implemented it a lot more quickly than other solutions that we've tried in the past because of that issue, because we're only a certain size company, can't afford 20 professors on the books. We have to have people who are going to fix problems, program machines, keep them running, and all the like. So yeah, we've had some great success with it. We had some products we were fighting a low-cost supply chain option with a large engine manufacturer, and we managed to reshore components out of basically an Indian supply chain back to the UK by applying some of this technique. We're pretty good in our own way with our own ways, but even from that benchmark, we got a 20% cycle time improvement across a family of 3 or 4 parts. So, you know, to go back to Sam's point on OEE, the OEE was high, but on paper, every 5th machine we were putting into those parts, we were losing money compared to a 20% improvement of productivity. So having high uptime is great, but you need optimized cycle time to be competitive as well. And we found this solution to be a great problem solver for us.
Yeah, thanks, Gareth. So, I mean, from an AMIC perspective, we're first of all, we're an innovation centre. So we're not academics, but we're not production. We're in this twilight zone in between. That's where we've lived. So we're helping businesses innovate, solve problems, and also access and progress the state of the art in manufacturing technologies. And a big part of what we look at is digital manufacturing, bring digital technologies to different disciplines. We've got a really good, innovative machining team who have come from the industry that we're here to serve. So these are people who've, time served innovators who work with and relate, with the businesses that we're serving. And the work we did with Erdem and the SenseNC, we've been partners for a few years now, actually, working together. Really impressed our team and the companies that we've engaged in Northern Ireland, where we're based. So part of it is, as Gareth said earlier, I think it's just, it helps you get a highly productive solution in a case where without this, people would lack the confidence to go and experiment and try, and there's a risk taking that experimental approach. What was really enjoyed was the integration with NX as well. So it is an ease of use. It's sophisticated. There's a lot of work under the bonnet that makes it easy to use, but you're taking some of that expertise that maybe used to be used with other tools that maybe a few of us have used over the years, and making that automated, easily accessible, and driving the productivity and quality benefits. So the example that I shared with that beautiful noise in the first demo, that was something we delivered, ran at our shop, and now we've got a number of businesses trying to understand about how do they access and start to deploy this. And it's at the heart of what we're trying to promote, helping companies become more digitally enabled to improve productivity, and partly this skills challenge. Right? We can't rely on, in fact, there's never been enough skilled users to really deploy the science that Gareth talked about for around 50 years. What this enables is deployability at scale, optimized solutions, getting the best out of the equipment, and not requiring PhD level skills to go and deploy it.
I can just echo that. I mean, this is, sometimes we are so excited by new technology, right? And we could forget the people in the game and my customers, right? And we have, on our Siemens backyard, we have developed hardware, software, functionalities, right? We have a saying, if Siemens would know what Siemens knows, right? What a great company would that be. But also the example here with Erdem, right? I mean, we have a lot of good people, but not all the smart people working at Siemens, I have to say that. So there's a few people outside. But I think what we are saying here, and AI is on my desk pretty much 10 hours every day here. We all hope and pray that this AI monster will help us to make it all simpler and easier. Will be quite a bit of work to get there, right? We all know that, but the hype and the excitement is there. But what I want to say is, I mean, and there was some questions in the chat here. I mean, in many places, I see the same software, the same technology, the same machine, the same controller, right? And you see that big variations of productivity, and there is, the people in the game, right, is a lot of time the hindering factor, right? It's the knowledge and how to apply things. I think this is what also Sam and Gerrit, you mentioned, right? I mean, if we have this monster technology and we only get, it's like you have a Ferrari with 12 cylinders and you forgot the gearbox and the tires, right? And you put more power in the engine and you still have a gap, to put the power on the street. I think that's one of the key stories what Erdem and team tries to do, to bring really these 10,000 IP years of doctors and research and professors right into reality and get it down to the machine and make it work, right? Not saying it's easy and a walk in the park and it's all just one button push and all is happy, right? But it's a big time achievement to get that really from the research and PhD. Sorry for the PhDs in the room. There's too many PhDs. Be careful about that.
We're not. Yeah, we don't bite. Don't worry, it's okay. We don't bite.
Okay.
I mean, Armin, you just mentioned AI right now, and of course it's top of mind of everybody right now. But how much of what we're seeing today is actually AI, and what role will it play for NX CAM in the future?
Well, that's a good question, and my team, we internally, I mean, of course, there's the Mark Zuckerbergs of the world, and people say in 2 years you don't need developers anymore. It's all done with a machine, and other people say 30% of my code is already written with a machine. Well, we also do all these experiments. So for us, this is a big game changer. And I see, I guess, our partners like Erdem, other customers even you guys, you may enjoy what we call wipe coding, right? And do your own little apps and little tools and little things here and there. You don't need to call a service guy to customize things, right? And if I would run a business to make websites these days, I would be in deep trouble, right? I mean, I can do, my team is getting nervous because I'm starting to use GitHub Copilot and Cloud Code and do my own apps where the people are really getting nervous. What is this guy doing now? He has no clue about code writing, right? So this will change a lot, but this is the software business in general. But the question is, I just got from feedback from Asia, the China company is not happy about the expert about our AI CAM Copilot, right? Well, what I always say, the AI, the beast, the machine, the large language model has a very good level on physics, on mathematics, on history, on Chinese, on Japanese, pretty much all on, let's say, junior high school or what level. But if you want to tackle the expert, the guy who is doing 20 years aluminum pocket machining, and you try with AI to beat him, that's stupid. This is the wrong place. So going back to what I said in the beginning, if we can make that AI tools, chats, the offerings, the service, I don't even want to call it software tools, help people to get to the 80% right in the first place, right? And make the system learn what experienced users learned for 20 years with trial and error. And that's also the thing what Adam showed us. When we teach the CAM system today, what do we teach? We teach them a toolpath and a tool and a CAD file and feed rate. But the real truth is when you go down to the machine and hear the machine vibrating or the tool is breaking, right? So that's really the learning feedback we need to get back into the first place. And this is where I think we need invest, that the system really understands, okay, if I do this radius cut here, that will vibrate, or this will break the tool. But you only learn when you really get the connection from the real machining feedback. That's the new goal. Let's say these data intelligence to connect what's going on the machine to what a CAM guy, a CAM programmer thinks will go on the machine. But you only know when you really do it with this material, with this machine, with this setup, with this clamping, with this whatsoever. And there's so many different parameters. That's where I think the holy grail sits. If we can master this and feed back into the model, into the trained model, as much of this information as possible. But the same customer in South China or in Finland or in Sweden or in Spain will have a slightly different setup because of temperature, because of different machines, because of you name it. So we need to make that what we call the IFM model. We are doing this industrial foundation model generic enough, but then you need to have a specific trained environment for these. For Garrett in the UK, for his machine, with his material, with his tools, that's a different game than what another customer in Portugal does, right? And this is where we are investing a lot. And honestly, we used to do roadmap for 1 year or two. These days, this is going so super fast, right? Every month, some change, some. How old is Cloud Code, Adam? 6 months?
Yeah, something like that. Yeah.
And it changed quite a bit the software world, right? And who knows what is in 3 months, right?
Maybe one thing I can add there is like agentic AI is very popular, like Cloud Code, they are very popular. But SenseNC is like an agent in that, so it's not using a like large language model. It's using physics in the background. So it's basically identifying all the problems related to physics on the toolpath, and then running a lot of optimization algorithms to find the best settings for the programmer, because there could be thousands of combinations of parameters. It's really difficult for a human to do it. But with this SenseNC agent, basically the CAM programmer, by pressing a few buttons or doing a few clicks, they get what they really need for the productivity. And one thing we really need to be talking about as well, Garrett said that they achieve 20% productivity, but there's a very important angle of reshoring, because when Armin started to talk about different countries, of course, each country have their characteristics. UK has their characteristics, which has some disadvantages compared to the low-cost economies. But using technology, even the UK-based manufacturers can be competitive. Maybe Garrett, you can share more about it.
Yeah, I mean, I can talk about my little microclimate that I operate in, because we're obviously not a huge entity, but we found that actually the global conflicts and the barriers that have been thrown up around them, trade and all that, has actually had an element of people thinking of more localized supply chains. So it means that often in the industries we support, which is sort of energy, aerospace and defense, everyone is reevaluating whether the air miles, maybe the products go, how many countries they have to cross before they go back to build line, and therefore there's a lot on the table at the moment in terms of the markets. And yes, that means they will still evaluate other low cost options, definitely, and in newer up and coming countries, beyond sort of China, India, and Morocco, and all these other growing economies. But they will also reevaluate Western Europe, and you even within that, you've got to be as competitive as possible. And that now it's a good time. Is what I'd say. It's a good time to implement something different. It's a good time to invest in something that's going to give you long-term gains. Because I'm actually not sure in 5 to 10 years' time that those questions are going to be asked again once these new supply chains stabilize. So we're seeing the benefit of that, where people are reevaluating, looking at different routes, different models of how they procure parts. But you've got to be competitive, and therefore that's why we tried to implement as much as we can over the last few years and the preceding 2 to 3.
Okay, so what we discussed is very compelling, and let's make it practical for our listeners and our watchers. Because if you're a machine shop owner right now, or a manufacturing engineer watching this, the question you're probably asking is, where do I even begin? So Adam, what's your response to like, how do I get started?
Great question.
How easy is it?
Yeah. Easiest starting point is SenseNC Fits is available in the Siemens marketplace, so they can basically purchase the solution, or they can do a free trial. So there's also a free trial option, so they can run 5 toolpaths optimizations free of charge. Maybe that's even the easiest option. Start with the free trial. If they like the results, of course, they can buy it, and then they will see 15, 20, 25% improvement in the productivity in a day. They don't have to wait weeks to have the return of investment. They will get return of investment in a short time frame, of course, depending on their production environment. But it could be days, weeks, or maybe a month or 2 maximum. And we also have a SenseNC Finesse solution, which is basically solving this hard problem of chatter vibrations. For that, we need to ship them a hardware kit for them to be able to measure the dynamics of their machines. But again, in a week time, they could start implementing the solution after a half-a-day training.
Okay, that sounds really good. So we are already closing in on our time, but before we're going into the questions, because I see we have a couple coming in through the chat. Before we get there, I want a very fast round. Each of you, in no more than 30 seconds, one thing machine shops should stop doing and one thing they should start. Adam, why don't you just continue?
Okay, they do a lot of iterations on the machine tools. They don't have to. I think that's the main message I want to give, because now there are solutions available. Of course, when you don't have the solutions, you only do what you can. But yeah, now there are solutions, so they don't have to do trial and error, and they can start using physics-based optimization to achieve the best part faster and first time.
If you want mine, I think it's a mindset change, and I know how difficult it is, and I still battle that internally, even though it's my company. But the mindset change is there's a lot of you in smaller manufacturing companies. You get a process running, and you improve it later. And if you go that way, you never get to, as I'm saying, you just sprinkle a little bit of benefit over a long time, and you always stay unproductive. And actually, the mindset needs to be optimized first as you prove out, as you make your first 1 to 5 components, and then you stick with an optimized process throughout. And I think if all machine shops or all entities had that mindset, I think that productivity gains will be there for everyone.
But for me,
sorry, go ahead.
Right, so a similar theme. I think the thing to start doing is to use the tools available to get things right first time. Right, so it's stop being suboptimal. Don't experiment and iterate. Use tools like SenseNC embedded in NX to get the solution right first time, so you just can do it once, leave it, and see the money rolling in.
Maybe I mentioned that before. What drives me really crazy in all the discussions I have, the shortage of skilled people. We already see, just a little anecdote from a Swiss company. They are going to hire bakers now to run their machines because they don't find people. I said, you guys are really bad. If I go on vacation one day in Switzerland, I want to buy some bread in the morning, there's no people making breads anymore. But this really I see around the globe in all the different countries and in China, wherever you call it. So I think we need to find a way to get our technology available for the next generation of users. So this is a big push, and save the old knowledge we have, the years of IP and experience, and make that available for the future.
All right, gentlemen, thank you very much for this nice panel. We have a couple of questions in the chat, and I'm just going through them as I see them here. So the first one is, do you also consider FRF or component?
Yeah, very good question. SenseNC automatically optimizes the feed rates and spindle speeds considering the tooling dynamics. Workpiece dynamics is not ready for automation at the moment. But having said that, we have done also pilots. In fact, we have done a pilot for AML. Garrett has seen the effect of it. So we can also include the effect of workpiece dynamics in our optimization, but that becomes like a pilot project rather than a software run. But yeah, we are able to do that as well. But not the SenseNC Finesse doesn't do it automatically at the moment. But productive machines with its very capable team can do it together with the development version of our software.
Yes, right. So just to simplify the answer, there's kit available. You can get the FRF measured through it, and therefore you can add to the model and strengthen it. Yeah.
Okay, and next question would be, how does this differ from OptiPath/Force?
Okay, another great question. OptiPath is only doing the optimization considering the material removal rates or chip thickness. So chip thickness also affects the process, but it doesn't capture like the vibrations, for example, or the things that I have described, like stresses, bending moments. Force is, as the name implies, Vericut Force does the force-based optimization. So it considers the force, but it doesn't consider the vibrations. The biggest selling point of SenseNC compared to OptiPath or Force is ease of use. SenseNC is embedded inside Siemens NX CAM. You basically do the optimization and you have new operations in the CAM environment, so we don't break the digital threads. So everything stays in the Siemens NX PRT file, for example. And then you can save it for 10 years, 20 years in the CAM. So we don't change the G code, we change the CAM file. So we see that especially large companies like that feature because they really want to keep everything inside CAM for traceability purposes. And also ease of use. As I mentioned, basically by clicking a few mouse buttons and then entering a few input, any CAM programmer can use the software. They don't have any engineering unit that they need to make a decision on in SenseNC. For example, in Vericut Force, they have to say, okay, I want 1500 Newton on this tool. I want 2300 Newton on that tool. So that's really a complex decision for a CAM programmer to make. But yeah, we eliminated all that complexity, and as Garrett or Sam mentioned, we hid that complexity from the user, but of course the complexity is in the software. So complex decisions are given by the software.
Very nice. So there's one more question here that I think is very interesting. When you require real-world inputs like tap testing, results, FRF, stability maps, how do you see that applied in high mixed low volume environments? Is it only for high volume production environments or also smaller shops?
Yeah, another great question. I think I will get that. I will have the answer. Or do you want to go, Garrett?
Well, it depends what the question refers to as smaller, but I mean, we've gone from 5 machines to roughly 25 over the last few years. So, I'd still regard us as small versus a machine shop in China with 7,000 plus. And we have a very high product mix of number of part numbers. But in essence, it goes to your application. And I think if you could embed it as part of your NPI process, where you bring in new products, you do the optimization inside the programming environment. That just becomes part of how you work, and therefore I think could be implemented even at sort of low volume, high product mix environments.
Yeah. So
this
great.
maybe
Thank you.
sorry if I may add, this is a very good point. In the last 20, 25 years, we also saw this closed loop mainly in the high volume. In the guys, they make 100,000 or millions of parts, right? And there's a lot of closed loop optimization. I think this is one of the real difference in the approaches, that you can do it for small batch sizes or even for one-off parts if you want, right?
Yeah. Well, one thing I would add is, even if you do high mix, low volume, many machine shops have their favorite tools. So they had a lot of parts are sharing common tools. So tap testing you do for a tooling assembly, like tool and tool holder on the machine once, and then you can use it in many different parts afterwards. So tap testing takes maybe 2 minutes to do for each tool. Of course, if you are measuring 10 tools, you need to maybe have the machine for half an hour or maybe 45 minutes. But yeah, so this is like an investment where you can get a lot of benefit afterwards. But I really recommend machine shops to start with their favorite tools, and then they will see the benefit, and then they can of course apply to all the tools that they are using. But yeah, they can easily start with a subset of the tools that they are using in the first phase.
Right. So I see our guardian angel in the back is already very active, responding to questions in the chat. Thank you, Christina, for covering on the questions. And I think we are at a pretty straight landing when we look at the watch. So I'll say that's a wrap, and we had a wonderful session today. I learned a lot, definitely, and I think you created quite some curiosity out there. This recording of the webinar will also be available if you want to go back once more. All of the gentlemen here on the panel are linked here in the webinar software. So if you want to reach out individually, you can. And yeah, if SenseNC, if that is interesting to you. Yeah, sorry, go ahead, Adam.
Sorry, I think there are a few questions that are specific. Maybe if you have a few minutes, like there is a question to Garrett, I see.
Sorry, yeah, I skipped those.
Yeah.
Question for Garrett. Yeah, how long did it realistically take before the results were visible enough to feel confident you'd made the right call?
Well, actually, ours was probably, it was a matter of weeks before we'd actually done first prototype parts, first implementation, and then ran a full first week of production. So yeah, you've got to see it. You've got to see it running. Don't get me wrong. You're not going to shut your eyes and you believe everything we just said. You're going to want to taste and touch it. But yeah, we had a week of slower going and understanding things, training and support, and then we had a week of running a batch of components through where those optimized parameters were implemented. And yeah, so it's pretty quick, I would say, generally for a solution. And there's a massive benefit for the interface. Don't underplay how the interface is very important. We all sit here and say, oh yeah, we can all use another piece of software. We can always export things around. But as you grow and as you manage your teams, multiple software solutions are a nightmare to manage, implement, and train and retrain as staff members evolve. So having it all in the same environment for your guys is a massive plus, and that was another reason why we could implement things quickly.
All right, and then
And
the
I
last
see-
question.
Yeah.
Can I realistically be used across all part types, or for an SMB trying to prioritize where to start, is there a sweet spot that gives you the fastest, most obvious return?
Maybe I can answer that. SenseNC Fits is the good starting point for a SMB because they can start quicker. In Garrett's case, we had applied the SenseNC Finesse. For that reason, it takes more time, but SenseNC Fits is the easiest starting point. Of course, it could be applied in all the milled parts. So the technology is working for milling at the moment. So any CNC milling machine, you can basically improve by 10-20%, maybe more. So the minimum saving you have shown up to this moment is 4% was the minimum saving. Minimum increase in productivity was 4%, but maximum was 110%. It really depends on where the starting point is. So if it is not an optimized port, the saving could be high. But in aerospace, usually companies are already doing some optimizations themselves before they engage with us. For that reason, there's 20% we usually mention. But one question I see is very relevant. I want to answer that as well. So there's a question about ModuleWorks and Autodesk partnership. So they recently released the smart roughing toolpaths. I haven't seen it myself, of course, because it's a very new product. They say they consider the physics of the machining processes in the toolpath generation, but that doesn't consider, for example, the stability. So because they are not considering the vibrations, there may still be vibration problems. But I didn't have a first-hand experience. But main thing is, the main unique selling point of our solution is the chatter mitigation compared to ModuleWorks and Autodesk partnership.
All right, and now I think we really had all the questions covered. Thank you very much, guys. Gareth, Sam, Erdem, Armin, it was a pleasure talking to you. As I said before, this conversation will be recorded. You can access it again. You will be sent the link, and you have all the information of the speakers. And if you're curious now, go ahead, go to the Siemens Accelerator Marketplace, look up the solution, and then you can get started right away, as Erdem showed today and described it. It's as easy as a few clicks. So I'm looking forward to it. And gentlemen, thank you again. It was a great conversation, and have a great rest of the day.
Thank you.
Thank you.
Bye.
Bye.